I'm here at Solid in San Francisco with Hasty Granbery, who's a developer on the Beacon project at PayPal. So tell me what you built.
Sure. This is the PayPal Beacon. It is a connected Bluetooth Low Energy device. So you can either connect it to just a power source and put it on Wi-Fi, or you can plug it into a PC with internet access. And it provides a Bluetooth Low Energy signal that you can then manage remotely through a RESTful API provided by PayPal. And then you can build applications on top of its platform.
Cool. And tell me about how you used Bluetooth Low Energy here. That's a pretty new technology that we're hearing a lot about these days.
Yeah, relatively new. It's part of the Bluetooth 4.0 spec. It's starting to find its way into phones. It's been in iPhones for a couple of years, and it's starting to show up in Android phones. It is a very, very power efficient way of sending small amounts of data between devices. So in our particular case, we're using it for proximity. So when you enter a store, for example, your phone can pick up the Bluetooth Low Energy signal being sent out by this device. It can then connect to the device. It can ask for information about the store, the type of store it is, the name, the location, things like that. And then either our app or other apps can make decisions based on that metadata.
So what sorts of decisions? These are transaction decisions?
They could be transaction decisions. They could be other things. The example I've been using today is if it was a pharmacy, you might walk in and it would talk to the beacon and realize that this is a pharmacy, and then the pharmacist could start preparing your prescription for you automatically.
So how much work did you have to do at PayPal on top of the existing BLE kind of framework to get what you wanted out of it?
Yeah, we had to do actually a significant amount of work. So there is an SDK that you can use in your app that automatically manages all the locations that you might be near. But also we built a secure tunnel on top of BLE. So there is some security in BLE, but it's actually oriented for different use cases. It's more for like personal devices. In our case, typically a beacon, the first time you'll see it is when you walk into a store. And in that case, the BLE built-in security isn't quite sufficient. So we build a secure tunnel from our app or your app through the beacon to our backend. And that preserves if someone's by eavesdropping on the signal, they wouldn't be able to get anything.
Interesting. So it's PayPal security reaching all the way from the service end into your phone.
Exactly. And that's part of the usefulness of a connected beacon. If your phone doesn't have connectivity, you can then ride on the connectivity of the store. So if you have poor signal or you're traveling abroad or whatever, when you show up in the store, all you need to do is make sure that the merchant has managed to figure out their internet connection and you can use ours. The other thing that's nice about that is that it preserves your privacy. So if you walk into a store and it talks to the beacon and gets some information about the store, if you then decide that you don't really want to do anything there, you don't care about it, we never find out that you were there.
So one of the things we're really interested in at Solid is, who's going to build the next generation of great hardware. You've done some cool advancement here on the beacon. Are you a software engineer or a hardware engineer?
I'm much more of a software engineer, so this has been my first foray into hardware. We have a whole bunch of very talented hardware engineers back at PayPal. It's been a very educational process for me. But what's I think really interesting about it is the degree to which hardware development is becoming more and more like software development. And you get much more rapid rapid prototyping times. From the initial desire to make this, we had a prototype up and working within just a few months, and that allowed us to figure out what we've done wrong and very quickly iterate to get another version of it. So this is actually the third version of the beacon in just the last year that we've been able to put out.
So how do you and your software colleagues at PayPal work with the electrical engineers, the designers? I mean, it's a beautiful piece of hardware. It looks like it's the result of a lot of work with a lot of people with different kinds of expertise.
Yeah, some of it's in-house, some of it's outsourced. So we worked with a firm down in the valley called Wiz and a design firm up in San Francisco called Fuse. So we gave Fuse the basic specs of the size of the chips on the inside, and then they worked on the externally facing shell and did a lot of work with the lighting. And then we worked very closely with the electrical engineering folks who are just one exit up 101, which is very convenient. So we were able to go and meet with them, they can come with us, and have a lot of back and forth.
So a lot of your work on BLE has had to do with building up two-way communications rather than just one-way communications, right? So what does that mean?
Yeah, so BLE is a very powerful technology, but that also means you have to be very careful with it. So some forms of BLE use just broadcasting. They send out a number, and then you can build something on top of that by phoning home to a server and figuring out what that number means. Maybe it means you're at a particular location. The downside to that is that in doing so, you've revealed your location to a server somewhere. And so a service that's built that way will inevitably form a track of wherever you move through the world, even if you're not using it. And we really wanted to avoid that. We don't want to build a spy network here where we're keeping track of all of our users. So if you get a prompt from a PayPal beacon, if you say no to the prompt or you just ignore it, we never learn your location. All that communication happened directly between you and the beacon. There was no third party involved. Now, once you decide to actually check in or do something else, then yes, you are revealing your location, but you're also getting some value for doing that.
Right, right. So it's hardwired privacy in a sense.
Yeah, basically. You don't have to trust us. You can just see by the nature of the packets that are going back and forth that nothing went home to PayPal.
Right, right. Excellent. Thank you so much, Hasty.
Great, appreciate it.